Welcome, matrix people. We're going to introduce determinants, and kind of an interesting tidbit on determinants here would be if we go into our calculator into the matrix section and we go to math, we'll notice this DET, that is for determinants, and you'll also notice this is not alphabetical by any means. So I take that to mean that the people at Texas Instruments feel like determinants is a pretty important thing that we may access quite a bit. And there's some really cool applications, and this lesson 7.7 has nothing to do with the applications of determinants. It's just finding them. So it's going to be a little bit mysterious, and there's some kind of weird things that go on when we get into things called cofactors and minors. But you're just going to have to take it on faith that we're going to learn what some of the uses of the determinants of matrices are. So 7.7, the determinant of a square matrix. If a matrix is square, it's 2 by 2, 3 by 3, 4 by 4, even 1 by 1, it has a number that goes with it that is its determinant. Now, I want you to understand that is just a one-way street. For instance, there could be a 2 by 2 determinant like this, or 2 by 2 matrix, excuse me, whose determinant is 11. But there are an infinite number of 2 by 2 matrices whose determinant is 11. So if we're told that a 2 by 2 matrix has a determinant of 11, that does not allow us to know the values inside the matrix. But if we're given the matrix, the 2 by 2 matrix, we can find its determinant. It's just not specific. So it's one-way street there. And I wish they would have just done this. I think it would be clearer if they would have said matrix A, let's say we have values in here A, B, C, D, then the determinant of it, note the determinant doesn't have the bracket. So this means matrix, where down here, this is the determinant of the matrix. And how we do that is just the downward diagonal product, A times D, minus the upward diagonal product, C times B. And that's what they've done here. A1 times B2, the downward diagonal, minus A2 times B1. Same thing, I just think it's a little more convoluted looking. Now, this minor thing, we're going to come back and take a look at this, but this minor and cofactor thing, we have a few opportunities during the year to give our graphing calculator a hug, and this is going to be one of them. You probably, very good chance, will never have to deal with minors and cofactors again after this chapter. But back in the day when we didn't have computers in our hands, finding determinants of anything above a 3 by 3 matrix was very involved. I remember finding the determinant of a 5 by 5, perhaps a 6 by 6 matrix in college in a linear algebra course, and there wasn't a thing hard but organizing it. It took about maybe 5 or 6 sheets of paper and an awful lot of time and like literally hundreds of little computations, and you couldn't miss one. Our calculators do that for us now, and I'm gradually introducing more and more calculator work with it, but there may be a time for one person in here where you're creating a program that's going to do what our calculators do for us, and you're doing it in, let's say, C++ or something like that, where you're going to need to know this in order to tell your calculator to solve, or in order to tell your program to solve this. So anyway, we'll talk about those as they pop up. We'll come back to this. And determinant of a square matrix, finding that we can use these, what are called cofactors, to find it. To find the cofactors, we have to find what are called the minors. And the minors are minor determinants from within them. They're like little matrices within a matrix's determinants. That makes no sense to you. It shouldn't. But as we go through it, I think you'll see at least mechanically what we're doing. Okay, let's get started. This will be a part 1 of 2 parts. First off, a 1 by 1 matrix has a determinant. It's not very interesting. If I just call it D, I'm going to say D equals, it's just the same as the 1 by 1. For the 2 by 2 determinant, as mentioned above, we take the downward diagonal product, -5 times 3, and we subtract the upward diagonal product, 6 times 2. It's always downward minus the upward. So in this case, we get negative 15 minus 12, or negative 27, is this matrix's determinant. And don't try to read too much into that yet. You'll see the applications of this as we go. Great time for you to try number 12. If you want to pause this, you shouldn't have to pause it long. In fact, perhaps you can do this one in your head. But good time for you to try it on your own. So our determinant is 36, the downward diagonal product, minus square root of 5 times square root of 5, 5. This one is just 31. Okay, now here they want us to find the determinant of this 3 by 3 just using our calculator. Okay, well, that's a good deal. We'll go on, we'll go second matrix, we'll edit a 3 by 3, and as you can see, I already have taken the liberty of entering this one. We've talked about creating matrices in our calculator, so if you're not certain what you're doing with that, go to some previous, go back to section 7.1. We do that in section 7.1, or come in and ask me a question if you're taking the class with me. Okay, so once we have that in matrix A, I'm going to quit out of here. I'm going to go back to matrix, and I'm going to go to math and grab determinant, and then second matrix, grab A, and there it is. It is negative 159.632. And I'm going to talk about a shortcut for finding, if you had to do this by hand for finding these, and we actually will do this in class, but I'm just going to show, I'm not going to go through all the computation. What you would do, here's a shortcut that works for 3 by 3s, does not work for 4 by 4s or 5 by 5s. You rewrite the first two columns. So there's column 1 again, and column 2, 0.2, 0.2, and 3.4. And then you take all of the products of the downward diagonal. So that's 5.1 times 0.2 times 0.4. You add to that this downward diagonal right here. 0.2, 0.2, 0.5. You add to that this downward diagonal, 7.3 times negative 6.3 times 3.4. You find all of those, and from that sum, you subtract all of the upward diagonals, 0.5, 0.2, 7.3. 0.5 times 0.2 times 7.3 plus 3.4 times 0.2 times 5.1 plus 0.4. Who am I going to run out of room here? 0.4 times negative 6.3 times 0.2. So really boxed myself in there a little bit. I apologize for that. So this is all of the upward diagonals products added together, and this is the sum of all of, this is all of the downward diagonal products, the sum of those, minus the sum of all of the upward diagonals. And test me on this if you want, but if you do that, you're going to end up with negative 159.632, and that's a mess on. But if these are simple little integers, I wouldn't have any problem with giving you a quiz or adding that to a test. In fact, you will. You will find what really helps is if one of these things, if there's a 0 in here every now and then, that cuts your work way down, because one of these products will be 0, and one of the downward diagonal products will be 0. But you'll see that. Okay. Minors and cofactors, and if this doesn't make sense to you, I'm going to ask that you keep referring back to here. But we're supposed to find all of the minors. So this is going to have a minor that associates with 11, a minor that associates with 6, negative 3, and 2. And the way we name those would be minor 1, 1, which means row 1, column 1. Coincidentally, that's 11, but this is really minor 1, 1. So minor 1, 1, how we get it is we go to 1, 1, this 11, we eliminate its row and its column, or its column and its row, and all we're left with is 2. And minor row 1, column 2 takes us, row 1, column 2 is the 6. We eliminate 6 as column, 6 is row, and we get negative 3. Minor 2, 1, row 2, column 1 gets us to this negative 3, eliminate its column, its row, and we get 6. And minor 2, 2 gets us to here, its minor is 11. Now, you would never go through the minor and cofactor process for a 2 by 2 because we do this to find determinants, and the determinant of this is 22 minus negative 18. 22 minus negative 18. The determinant of this is 40. Okay, then from the minors we can find the cofactors. Cofactor 1, 1 equals, it's either going to be 2 or negative 2. Cofactor 1, 2 is either going to be negative 3 or 3. And here's how we determine which. If you look right here, cofactors are equal to, cofactor row column is equal to negative 1 plus the sum of the row and the column. So if I take negative 1 to an odd power, it's the opposite of the minor. If I plus j is even, this becomes positive 1. It's the same as the minor. Weird. The crazy thing is to think that somebody thought of this, and there must have. People don't get bored and do math. I mean, some people do. I'm not judging. But most people that are doing this stuff are doing this for a reason. There must have been some reason, and you'll see the value of this as we move on. Okay, so anyway, minor 1, 2, or cofactor 1, 1. 1 plus 1 is 2. That's even, so it's the same as minor. But cofactor 1, 2, 1 plus 2 is 3. It's odd, so we get the opposite of negative 3. And cofactor 2, 1, 2 plus 1 is odd. We get the opposite of 6. And minor 2, 2, 2 plus 2 is 2, so cofactor 2, 2 is the same as minor 2, 2. It's 11. And how we utilize this is you can use any row or any column to figure out the determinant. If I was to, for instance, use row 1, we would say that is 11 times cofactor 1, 1, this guy's cofactor, plus 6 times this guy's cofactor, that's cofactor 1, 2. So in this case, that's 11 times cofactor 1, 1, 2, plus 6 times cofactor 1, 2, 3. And remember when we said, wait, it's 22 minus negative 18, 40. This is 22 plus 18, 40. And the crazy thing is that works with any row or any column. We'd get the same value, 40. These would be different, but the numbers we'd get would add up to be 40. Okay, 420. It wants us to find all 9 minors and cofactors. I'm going to ask in that set, if you get a 3 by 3, we just find 1 row or 1 column's worth. I'm going to do row 1. Actually, just to switch things up, I'm going to do column 1. We're going to go with column 1 here. So I want minor 1, 1. I want minor row 2, column 1. I want minor row 3, column 1. So the minor 1, 1, we go to the negative 2, that first position, hide its row, its column, and we find this guy's determinant. Well, this guy's determinant is 36 minus 0. We see it? Minor 2, 1, we go to 7's, we go to this position, row 2, column 1, eliminate its column, its row, and we get 9 times negative 6, negative 54, minus 7 times 4, minus 28, we get negative 82. And row 3, column 1, we go here, eliminate these, and we get that guy's determinant, 9 times 0, 0, minus negative 6 times 4, negative 24, we get 24. And then cofactor 1, 1, 1 plus 1 even is 36. Cofactor 2, 1, 2 plus 1, 3 is odd, opposite of negative 82, 82. And cofactor 3, 1 is 3 plus 1 even. is 24. So if we were going to complete this, and I'm just going to set this up, we would say our determinant is equal to, it would be this column's values, negative 2 times its cofactor, plus 7 times its cofactor, plus 6 times its cofactor. And we can do that calculation. They're not asking for it here. They are asking for all minors and cofactors, so they're really asking for us to find minor 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3 as well. I'm good if you give me a whole row or column worth on that. Okay, and then we're actually going to use minors and cofactors to find this. And I'm going to, 21 and 22 are in your assignment. I'm going to do this portion of the assignment for you, leave you column 2, and I'm going to do this portion of the assignment for you and leave you with row 2. And what they're doing here is just letting you know, hey, it doesn't matter which way you do this. So for row 1, the determinant is going to equal negative 3 times cofactor 1, 1, plus 2 times cofactor row 1, column 2, plus 1 times cofactor row 1, column 3. Well, row 1, so for cofactor 1, 1, I need minor 1, 1. I need minor 1, 2. I need minor 1, 3. So minor 1, 1 is, can we do this one in our head? 5 minus negative 18, 5 plus 18, 23. For minor 1, 2, we need downward diagonal 4 minus upward diagonal 12, 4 minus 12, negative 8. And for minor 1, 3, we go to 1, 3, eliminate its row and column, and we get negative 12 minus 10, negative 22. Cofactor 1, 1, 1 plus 1 even, 23. Cofactor 1, 2, 1 plus 2, 3, odd, positive 8. Cofactor 1, 3, even, negative 22, stays the same. So our determinant here, sorry about that, our determinant here is negative 3 times its cofactor plus 2 times its cofactor plus 1 times its cofactor, negative 22. And I will leave that to the reader to go ahead and multiply that out. You'll have this in your notes, but you'll add column 2. Should be the same result, but the process for column 2 is similar. All right, column 3, so we're looking right down here. So that's going to be 2 times cofactor row 1, column 3, plus 1 times cofactor row 2, column 3, plus negative 8 times cofactor row 3, column 3. So we need minor 1, 3. Ooh, that's terrible. Minor 1, 3. We need minor 2, 3. And we need minor 3, 3. Minor 1, 3 is negative 42 minus 12, negative 54. Minor 2, 3. 2, 3 is right here. So we eliminate its column, its row, and we're left with negative 3 times negative 7, 21, minus 4 times 4, 16, 21 minus 16, 5. And minor 3, 3 gives us negative 9 minus 24, negative 9 minus 24, negative 33. Cofactor 1, 3, 1 plus 3 even, stays the same. Cofactor 2, 3, 2 plus 3 odd, opposite of 5. And cofactor 3, 3 even, stays the same, negative 33. So our determinant is 2 times its cofactor, negative 54, plus 1 times its cofactor, negative 5, plus negative 8, times its cofactor, negative 33. And again, I'll leave that computation to you. I'll leave row 2 to you as part of your assignment. You're going to do that. And I'm telling you, once we are done with this chapter, chances are, if you forget one topic we've covered in here that's not going to damage you, this may be it. But I did want to introduce that, so maybe somewhere down the road you see it again and there'll be at least a little bit of background in this. We've got some more examples to talk about from 7.7, but we're at the 20-minute mark right now, and I've got a class about to start, so let me know what I can help you with through this assignment, as always, and stay tuned.